will have the opportunity to discuss it further on also all of us make all the conservation question and recommendation we want to make. So thank you very much for giving the talk.
Thank you.
Okay, I have to sit. So, good morning. I apologize, but I have to speak in English. I understand Spanish, but I can't speak it. And I would like to say thanks to Jose for inviting me to be here. It's a pleasure. I'm enjoying everything up to now. And I'm here to present a work in progress that is a joint work with my colleague, Victor Moutinho. We are both from the University of Aveiro. And I will present a new LDMI decomposition approach to explain emissions in the European Union, individual and set contributions. The outline of my presentation, I will present the goal, our main motivation to do this work. I will present some of the data that we have been using, the methodology and results, and some discussion of these results and the conclusions that we have reached up to now. So this study mainly breaks down carbon emissions into 6 different effects for the set of the complete European Union 28 countries. And after that, we divide this whole group into 2 different groups. The first 15 countries entering in the European Union, and then the other 13. We analyze the evolution of CO2 emission changes through time using a larger data span from 1990 until 2014 to determine which had more impact in the intensity of emissions. And we also break down the complete period into 2 distant periods, the pre-Kyoto one until 2004 and after the Kyoto Protocol, to see if something changes. The complete additive decomposition has been used to examine these CO2 emissions, and we have used that as components the carbon intensity, the changes in fossil fuels consumption towards total energy consumption, which we call the EM effect, the changes in energy intensity effect, imports of total oil products intensity, total petroleum products effects, or the per capita dependence of oil products, and the change in population. What was the main motivation to do this? And we are just starting this work. We believe that it has a lot of things to we can take a lot of things from here, and we can even split the complete analysis because it's too huge up to the moment. And the main motivation is the growing environmental conscience that has led to the accomplishment of policies to modify the behavioral patterns which are observed concerning emissions in some European countries. Examples of these policies are the Kyoto Protocol, the 2020 strategy, and the growing use of renewable sources, as we know. But still, many of the European 28 countries are still oil dependent, and we have decided to join in this decomposition analysis also the oil dependence effect. For example, the Europe 2020 strategy aims to turn the European Union into a so-called low-carbon economy based mainly on renewable sources and energy efficiency, in accordance with Eurostat 2015. The Europe 2020 strategy sets 3 main goals for climate and energy policy to be reached by 2020. reduce GHG emissions, increasing the share of renewable energy, moving towards a 20% increase in energy efficiency. Additionally, this strategy points out that the European Union is committed to take a decision to move to a 30% reduction by 2020 compared to the 1990 levels. That's why we have decided to pick up the entire period to see what's happening up to the moment. The European Union dependency on energy imports, mainly over oil and more recently of gas, forms the backdrop for policy concerns with respect to the security of energy supplies and still influences the performance of high levels of CO2 emissions. As pointed out in the Energy Production and Imports report of Eurostat, there has been a shortfall between production and consumption and a clear European Union increasing dependency on energy imports from non-member countries. More than half of gross inland energy consumption in 2013 came from imported sources. And the fact that they are net oil importers can also help to increase CO2 emissions when the goal is to decrease them. In 2010, all member states developed their national renewable energy action plans, detailing how they plan to reduce emissions and to achieve the targets that they have promised to do. But still, and in accordance to Eurostat 2015, the European Union was increasingly reliant on primary energy imports to satisfy demand, although there was an evident slowdown and stabilization among the period of the financial and economic crisis. The EU28 imports of primary energy exceeds exports in 2013, and the largest net importers of primary energy are the most populous European Union member states. Denmark from 2004 until 2013 was the only net exporter among the member states, but in 2013 the situation reversed, and presently there are no longer European Union member states net exporters of energy. The largest net importers were Luxembourg, Malta, and Belgium from this set. So we use the additive decomposition technique in two distinct periods. As I said previously, 1990 and until 2014. We divide the complete set into two different groups, the EU15, the first one, and the last 13 countries. We have added to previous literature and from what we were able to see, two different new decomposition effects, the imports of total oil products intensity and total petroleum products effects, or the per capita dependency of oil products, as we have called it here, or the PP effect. This study relies on a different group of variables, including also imports, given that fossil fuels are connected to energy production and consumption, and these are accounted for in the factors carbon intensity and fossil fuel energy consumption. The imports of total oil products hasn't been accounted for previously, as far as we are aware, and this allows us to consider the dependence of imports connected to transformation and supply. Oil imports dependence per capita is presently also accounted in the CO2 decomposition, and the current work, besides using the drivers already used by previous authors, we had to do the decomposition, the so-called compensation factors, different from a previous work that we have this time with Vitor Moutinho, Pedro and me. But we use two different additional contributors. The present work has the advantage of contributing to previous research in several different ways. First, following the LDMI decomposition, we have used these two different drivers, or have included carbon intensity, energy intensity, fossil fuel energy consumption, These are all factors that have already been accounted for in the literature, but we have the oil imports intensity also, the per capita dependence of oil products, and also the population effect, also commonly used in this CO2 decomposition literature. Second, the CO2 mitigation in the EU28 is analyzed into distinct periods, before Kyoto and after Kyoto Protocol, to evaluate the impact of the entry in force of energy emission policies. Third, our third contribution is with respect to the decomposition, which is used to identify the driving factors of emissions related to energy and allows to explain the differences in the levels of efficiency among European countries. Fourth, besides identifying the most relevant contributors, we aim to do a comparative analysis to contrast the performance of the different countries with the goal of providing policy guidance for other countries. Fifth, we have used the entire sample and analyzed them also in an individual way, besides considering these two different groups. So we believe that we have many contributions to previous literature, but we are still working on this. The fight against CO2 is linked to climate change. The levels and the search for energy self-sufficiency should encourage the wider use of cleaner sources and be able to promote the mitigation of carbon emissions. If we are able to decrease the dependence over net imports of oil, this should also lead to the reduction of GHG. If we decrease imports dependence and this takes us to increase the generating capacity from renewable sources, then we will have a positive effect on reducing CO2 emissions. That's what we try to see if we already have this or not. So with respect to the data that we have used, we cover annual data from 1990 until 2014. We have after divided this into two different periods. The set of the 28 countries are here by the dates they have entered in the European Union, and these countries have been separated in the two distinct groups, those whose entrance was until 1995 and those whose entrance was after this period. The variables used were GDP, the gross domestic product at market constant prices of the year 2005 in million of euros. We have the sources of the data here and in the article also. We have used GHG, the total greenhouse gas emissions caused by consumption of energy in thousands of tons. We have used fossil fuel consumption measured as the sum of final energy consumption, computed as the sum of final consumption of solid fuels, gas and petroleum products in thousands of tons of oil equivalent. Imports of petroleum products represents total imports of oil measured in 1,000 tons, and population was retrieved from the World Bank data and is measured in 1,000 inhabitants per country. With respect to the methodology, we expect the results of this decomposition analysis to show which effects are more crucial to reduce the CO2 intensity in each of these EU28 countries, and we are going to present the results separately for these three different groups. We decompose the various effects of CO2 emissions using LDMI, as other authors also do. The methodology is widely used and its results are pointed as robust and consistent. The changes of CO2 emissions were decomposed for each of the two periods, and these were made between a base year, year 0, and the target year, year T, denoted by the change of CO2, which was after decomposed into 6 different effects. The changes in carbon emissions of each EU country with respect to the fossil fuel consumption in that same country. The EM effect captures the fossil fuel of each European Union country related to the total of of total energy consumption. There is a mistake there in each country. The EI, or the energy intensity factor, is the fossil fuel coefficient for energy consumption. The EP factor is imports of total oil products intensity in each European Union country, which relates to the increase or decrease investment for mitigating the imports of total products of oil. The fifth term, PP, which we call PP, is the total petroleum products effect, considering supply, transformation and consumption of oil per capita. The sixth term is the population effect, or the total number of persons in each country. The model, the decomposition that we have used, and each of the factors are stated in equation 3. We have computed changes, always with respect to the base year and the target year, 0 and t, in order to be able to compare different periods of time. And the formulas used are all stated in the article also. Compared to our previous work, we have considered at least four same factors to decompose CO2 allowances, but we have added two more effects with respect to energy imports, namely oil products import dependence for each country. In this work, we substitute their decomposition factors, which were with respect to renewable capacity productivity and the change in capacity of renewable energy per capita, and we change it by the imports per capita and also the imports intensity for each country. So we believe that this will provide more reliable information. With respect to some of the results that we have achieved up to the moment, here we have the complete set of the European 28 countries, and we have computed each of those effect changes with respect to CO2 emission changes throughout all the years considered in the sample. And we see here different effects. Not all the results are as we were expecting initially. We still have to work on the policy implications of these results. We didn't have time up to this moment. The positive signs means that we have these effects as drivers. The negative signs means that they work as compensators. And with respect to this data, the most significant reduction in CO2 emissions we see happening in 1991, 2007, 2009, 11 and 12. And the main contributors for this reduction are the PP effect and the per capita dependence of oil products and the carbon intensity factor, and more recently also from energy intensity factor that we have considered in the decomposition. We see that in the EP effect that we have considered, imports of total oil products dependence, is in most all of the years, or it reveals to have in most of the years a positive sign. So this indicates that these countries are still highly dependent on oil imports, and this has a larger contribution in terms of CO2 emissions. So this could give a sign to change or reverse and bet more in the renewable sources that has requested by the European Union impositions through time. We also have here a plot for the effects with respect only to the first set of European Union 15 countries, and we see some differences with respect to the complete set, namely in terms of the amounts of reductions. We have the population effect here with high values at the beginning of our sample, then it is reducing through time. with a positive effect. The EP effect is, as always, a positive sign, or in almost all years, except in 1991 and 2008, which has a negative, which is a contributor and not a driver of CO2 emissions. Sorry, but we have changes in science through time, meaning that we have here a huge heterogeneity, and we need also to account for this heterogeneity when we discuss properly the results that we have achieved. With respect to the sample of the European Union 13 countries, values change. Now we have a positive EP effect, which is our imports of total oil products dependence. We have a positive effect in 1991, also a huge positive impact over CO2 allowances in 2008. In the group of the 15, we had a negative one. So we need to consider that these are the most recent countries that have entered the European Union. A lot of efforts have already been done with respect to these countries, but a lot more remains to be done in this respect, or for CO2 mitigation. But curiously, in 2013-2014, we see a lot of negative impacts over CO2 emissions. The only positive effect was with respect to the imports intensity, EP effect, and for 2014, the carbon intensity effect, which was positive and compensated the negative effects of the other contributors. So in total, CO2 emissions seem to still increase during the different years. Here we have a sample, a summary of the results that we have achieved, but measured in percentage contributions to the total variation of CO2 emissions. We have each change in each effect considered in the work throughout all the years that we have considered. We have the variations in CO2 and the contributions. For example, we have in 1991 a contribution of the carbon intensity effect of 54%, which is positive because the total variation of CO2 has been negative, and the impact or the effect of carbon intensity is also negative. When considering the ratio, the percentage turns out to be positive. But we can take some more information from here. We have huge changes through time and in different years. The years of 2005 or after the Kyoto Protocol, we see that in fact, or the results seem to indicate that the post-Kyoto period has provided or has given the expected results that they were initially that they initially wanted, because we have huge negative reductions considering these effects, but still a lot needs to be done. We wanted to consider other methodologies to explore deeper these effects, but we didn't have time to I have to be honest, we have prepared this work in order to be here today to present some of our analysis or our research, and we didn't have time to explore deeper all the results that we have obtained, but we have tried to give some other contributions, and these are also explained in the working paper version. We have here a plot of we have considered both eco-efficiency and energy intensity in one side, and the eco-efficiency and the intensity in the use of oil products, to plot and to see in which position each of the countries are up to each period of time, and considering the different groups of European Union countries. We have here the plots for the EU15 and only for the pre-Kyoto period, and we see that Sweden has the highest position when we consider both the eco-efficiency level of the country and the energy intensity it has. We have in the lowest position Greece, but when we look also to the set of eco-efficiency with the intensity in the use of oil products, we see that Sweden still has a dominant position in this plot, but France, for example, and Denmark have gained position with respect to other countries when we also consider the intensity in the use of oil products. Netherlands, we see that in Netherlands we see it deviating when we consider the intensity in the use of oil products, and Portugal is a little bit better when we consider the intensity in this usage. Here we have the same EU15 country group, but for the post-Kyoto period, and the idea was to compare with respect to the pre-Kyoto period and see if things have changed. We see that Sweden still remains with the highest position among this set of countries. Luxembourg is the fastest country when we consider the intensity in the use of oil products. Greece is the worst of all, or remains lower in terms of eco-efficiency, and we also have a strong position in Sweden when we consider eco-efficiency and the intensity in the use of oil products together. And this can provide us highlights about the stage at where each of these countries is up to this moment. We have the same plots, before going to the other plots, we can say that improvements in eco-efficiency are the result of improvements in emission reductions. Countries in the north of Europe like Sweden, Denmark and Finland, and countries in the south of Europe, France, Italy, Spain and Portugal, have increased their renewable resources in the post-Kyoto period, with the increased use of fossil resources which are less pollutant, like the combined gas and fuels oil cycle. In the process of energy production, as well as increases of hydro energy production and nuclear reduction, turn out to reduce the dependence over fossil fuels. When we look to the EU13 group, we have the same plots, the pre-Kyoto plots and the post-Kyoto plots. I will show them in the next slide. We see that in this set, Malta is the country which seems to be leading in terms of the eco-efficiency and energy intensity rankings. Bulgaria, Estonia and Romania are the lowest one. When we look at also the joint set of eco-efficiency and intensity in the use of oil products, we see that Estonia, Lithuania and Bulgaria occupy the lowest positions of all. With respect to the post-Kyoto period, the position of Bulgaria is even more distinct from all the other countries. Malta is still leading after the Kyoto period, and all the others remain almost together in terms of the joint game, if we can call it game, of eco-efficiency and energy intensity, and also eco-efficiency and in the intensity in the use of oil products. So in terms of main results, we could say that results found in our study up to the moment, in the turnaround of the post-Kyoto period and with respect to the pre-Kyoto period in the EU15 group, clearly show that improvements in eco-efficiency are the result of improvements in emissions reductions, mainly due to changes that have been occurred in the energy mix of these countries in terms of production and consumption, with a focus in the change of energy resources uses which are more efficient and less polluting, and we have this stated in several reports. The relative contributions of these two factors in the decomposition method show the importance of the effect of imports productivity to the supply and transformation of the use of petroleum products in energy production for final consumption. We have added the effect of energy intensity with due impact in the change of the energy mix structure and the subsequent changes in emission levels. It seems evident that countries in the north of Europe and countries in the south of Europe have increased their renewable sources in the post-Kyoto period. This is mainly due to the use of fossil resources which are less pollutant. In accordance with the previous figures, we can say that for the group of countries belonging to the EU13, those which have joined the European Union later, we may infer that countries like Malta, Cyprus and Slovenia exhibit in this period a high level of eco-efficiency associated to a reduced energy intensity and also with a reduced intensity in the use of oil products. By opposition, Bulgaria, Estonia and Romania present lower eco-efficiency levels jointly with high levels of energy intensity and high levels of use of oil products and derivatives. In the post-Kyoto period, and Malta continues to be the country inside the European Union, 13 countries, with a better positioning in the joint relationship, eco-efficiency and energy intensity, and on the other side, Bulgaria continues to be the country presenting the worst level of eco-efficiency and a higher energy intensity, at least as revealed by the data that we have used. It was possible to observe from the results that the effects energy intensity and imports dependency are the main responsible for the total and negative changes of CO2 emissions in 2014. In the pre-Kyoto period, it is registered in the aggregate EU28 a tendency for positive and significant changes in CO2 emissions. In the period 2010-2012, we verify a new change in emissions where they have increased, caused mainly by the energy intensity and the EP effect. In 2013 and 2014, we have a decrease in total changes of emissions due mainly to the EM and PP effects, and the negative emission changes can be attributed to energy intensity and the PP effects. There is a clear evidence of different adaptation velocity to challenge and compromises with respect to the adherence to the Kyoto Protocol. This was translated into different positive and negative impacts in the change of behavior of CO2 emissions throughout Europe, as we were able to see by the primary analysis that we have done to this decomposition. So, for my presentation, it's all. Thanks for your attention, and we would like to say thank you once again to Jose Cancino for being here.
Thank you very much for your interesting remark. Now, we should myself to each view. My first comment is about the